Buenas tardes, me llamo David o Ink 80. Estoy muy feliz estar aquí con ustedes. Yo estoy casado con el amor de mi vida y ella es brasileña y estoy aprendiendo portugués. Entonces, disculpe, necesito hablar en inglés porque no hablo español bien. Thank you for joining me. This talk is AWS IAM Privilege Escalation. ¿Cuántas personas, quién aquí está usando AWS? Awesome. So we are going to talk about how to protect yourself in AWS, but this talk really isn't so much about like tools like Paku or Endgame or Cloud-splaining. It's more about using the control plane to hack in AWS environments. It's a bunch of like pen test stories and red team operating stories where I just tried things that probably shouldn't have worked, but they did, and I was able to escalate privileges. Now, I think this is important because instead of a gas bill being so high, it's the cloud bill being so high, right? If your AWS bill is so expensive, or Azure or GCP, your business doesn't do business anymore because you just paid your cloud bill. So I want you to please take away tips, ideas, thoughts on how you can keep your cloud bill low so that your business does the thing that your business should do instead of paying extra money to your cloud bill. So this is me. I love to hack computers and make rap music about it. And you can follow me on the internet for all kinds of memes about hacking and rap music. Okay, so I want to acknowledge prior art before I started. There was a lot of excellent research about AWS hacking that's already on the internet. If you have looked at AWS hacking before, you likely know Rhino Security Labs. They have published amazing things. But I wanted to highlight specifically this last one, hermetic.com, because I really appreciate the methodology, the thought process that they document into the research on this particular link. So please take a photo, look through these. So many resources out there, but I hope that we all learn more about cloud hacking in this particular talk and from hackers across the planet. Okay, so here is my thesis statement. In any environment, cloud environment, traditional network, you have some sort of authorization access control mechanism. And those mechanisms are so important. So you have to tightly control them to make sure that you are getting the access that you desire, right? You don't end up with situations like the ones you will see in this talk. Okay, very quick core concepts. An IAM user is like an account that you're probably used to with your regular usage of computer applications. There's some kind of credentials for it. And so when we think of an AWS account, an IAM user is an individual entity inside of that, right? Like you have a Twitter, you think of Twitter as like your service, and then your IAM user would be your Twitter account. An IAM group, you can collect groups of users. So Facebook, you have your Facebook account, and then you have a bunch of Facebook accounts in one group, and so that's your IAM group. And then a role is similar to a user, but it's temporary access usually. You'll join, you'll assume into a role, which means you start accessing and using the role to assume into it. And then it's timed. The session expires anywhere, I think, 15 minutes to 12 hours. So we like IAM roles. They're not static credentials. They're good. And then a policy. The policy is what dictates who can do what, to what resources, and under which conditions. So you might be able to create a new EC2 instance, or like a VM in the cloud, but you can only do that if it's a certain instance size, like it only has 2 processors and 2 gigs of RAM. And a good way to up your cloud spend is to spin up a bunch of EC2 instances with a lot of processors and a lot of RAM and a lot of GPU and mine cryptocurrency. Okay, so as we go through these, I want you to think, for all of us who are using AWS, does my AWS environment prevent, detect, and or alert if this situation were to occur? So first one, create access key. It's an API inside of AWS, which you use with IAM users. So when you create an IAM user, if you want it to programmatically talk to other systems and services inside of AWS, it has API credentials, right? Everything in AWS is APIs. And so what's awesome is you would think normally about a regular account that you have, and it just has one password, right? That's it. You know the password for your Twitter account. But in this case, you can actually have multiple access keys or access credentials for an IAM user. You can have two. So you might try to get access to a particular IAM user. You don't have those credentials, but maybe you're able to add a second set of credentials. And when you do that, it tells you what the credentials are. So then you gain access into that privileged IAM user. If you try to add a third set of credentials, you'll get this limit exceeded exception that gets raised. So this is what it looks like. Here's our create access key API, and we're just saying, hey, we would like to get new credentials for this admin user, and it tells us, here is your access key ID, and here's your secret key. And with those two components together, we can now begin using this admin user, even if we didn't have credentials for it before. So that admin user is, more elevated, more privileged, and now we've gained access to it. One of the things I like about create access key is if you think about traditional hacking, I get a shell on a Linux box or I get a shell on a Windows system. I'm probably going to add some new account to that, right? I create a new user. And so in doing that, that shows up, it stands out, especially if I name the user poorly, right? If everybody is named Bsidesco dash and then something else and I name it LOL int 80 or hack all the things, it looks weird. And so by doing this, we're not adding any new users. We're not creating anything that looks strange. We're just adding a second set of access keys. And I've been in some environments where they programmatically track and rotate their known sets of access keys. So I was in one place where any IAM user, it had just one set of access keys, and they would rotate that programmatically, which is great. So if those were compromised and they rotated the next day, no big deal. But in adding my second set of access keys, now those didn't get rotated, and I continued to persist access in that environment. So it's very low touch, not disruptive, and a potential way to escalate privileges. Create login profile. Okay, so what we just showed, right? There was a there's a terminal, right? And so it doesn't look flashy. It's not easily human parsable. But create login profile is for the AWS web console. So that's when you go to your web browser, you type in aws.amazon.com. It's much more easy to use from a human perspective. And so what we can do is say that we have a target IAM user that we want to get access to. We can create a login profile for it, which will give us a chance to set a password on the account, similar to creating access keys, except we're accessing that IAM user through the AWS web console. So if you try to do this and create an additional login profile, you'll get this error raised, entity already exists. And then if you are successful in creating a login profile, you will then be able to potentially access the account, but you should always look around, try to not get caught. So if you have an IAM user that has never used the web console before, it probably doesn't have MFA on it, for example. And so if you look around and you see all the other IAM users that do have a login profile have MFA devices, you should put an MFA device on the IAM user that you just compromised. Account password policy as well, how do I make passwords that fit in, we all know GPO or enforcing password requirements, so create a password that fits in. And this is what it looks like. So we're just calling create login profile and specifying the user and a password that we want. You can also set force the password required or force the password reset. So as example in shell history, you can go back and look that I used this password a better password than hack all the things, one exclamation point, you could pull that password out of the shell history and then say, oh, now I also have the password. So you can force a password reset, but this is all it looks like, create login profile. Okay, in this scenario, deactivating an MFA device. So you compromise credentials for some login profiles that has access to the AWS Web Console, right? So I have the IAM username and I have the password, but I go to log in and it says, okay, input your 6-digit code that changes every 30 seconds. And I don't have that. But what I do have is access, what I had in this case was access to a different IAM role that allowed me to turn off the MFA for that privileged IAM user. So then I was able to just go back to the web console, use the username and password that I'd compromised, and bypass the MFA. Always fun. So this is like a condition that you'll see AWS multi-factor auth present that forces that MFA requirement. And so if we deactivate the MFA, now we can log in. But avoiding alerting, right? There's an IAM user that should have MFA and it doesn't. So we just create a new MFA. No problem. Now we have the MFA, so we can provide that code. The other person can't. That's okay. But we do. So it's cool. So you create a new device and then enable it. And this is what the deactivate call looks like. Deactivate it, and you can pull the current MFA using other APIs. I forget what the specific API is in IAM. So again, we're thinking, does our environment prevent this? Like, do we allow people to create login profiles? Do we allow them to create access keys? If they do we detect it? Do we alert on it? Do we say, all of the IAM users in our account or in our AWS account only have one access key? Suddenly, now there's 2 access keys on this IAM user that's highly privileged. Is that an alert that fires, and do we look into it? Let's talk about groups. So I was in an environment and there was a privileged group. So I was like, well, this probably won't work, but I'll try it. There's an admin group that has administrative privileges. My current user is not in that group. Can I just add myself to the admin group? And in that case, it worked. and this was it. That's all I had to do was just add myself to the admin group. Like, I am the admin now. Okay, cool. It's worth trying. You never know what's going to work. Creating a group. Okay, let me think about this one. Okay, so this one was interesting. There was a security team that went through a rebrand. So they were like the IT security admins originally, and they wanted to be named now the cloud security admins. So what happened was they changed their names. So they changed like the IT security admin group to be named Cloud Security Admin Group. And they tested, does everything still work with the Cloud Security Admin Group? They added Cloud Security Admins into their policies everywhere that they had IT Security Admins. They left IT Security Admins in place just in case something didn't work. They could revert, no problem. But then they did not update the policies. So the policies allowed administrative permissions for both the IT Security Admins Group, which no longer existed because they deleted it, and the Cloud Security Admins Group. So I was able to go in and just recreate from scratch the IT Security Admins Group, add myself to it, and then I got administrative privileges. So it's kind of like, it took some, digging around in the policies and understanding the mental model, but it was a great find. It felt like a subdomain takeover. If anyone's done a subdomain takeover, you find a site references an S3 bucket that no longer exists. You go create the S3 bucket and put your own content, and now that website serves up your content. So this was a fun one. In the event that you don't have the create group API, you're not allowed to use it. In this case, if I could change my existing group's name, what I could have done was, say I was in a group called developers. I could have run update group to then change the developers group name to IT security admins. And so then that still would have gotten me this particular privilege escalation. And this last group's one, in the setup, I was in a group where it was very restrictive. So if I could get out of the group, I would get more permissions, more access. So the group's policies, they used to deny. If you tried things, you were very limited in your actions available. And so being in the group is truly the restriction. So what I was able to do is say, take me out of the restricted group, please. Just like remove me from the group. And that worked. It was another one where I was like, I don't think this will work. But it worked. So I was able to escalate privileges this way as well. So my not administrative user took me out of the developers group, which was limited to only certain actions for developers. I got more permissions. So it was a nice privilege escalation. I want to take kind of like a detour here just to think of, or talk through kind of how I think about researching things like this, like how you can go about looking into other areas this exact same way. So first off is recon, right? We do reconnaissance, we look around, see what we can see, what can we find. So in AWS, I'm looking at preventive controls. What is limiting me, or what's going to limit me as I try to hack further? And so with preventive controls, usually I'll look through two main areas. One is infrastructure as code, right? So if I'm in an environment that uses Terraform or CloudFormation templates, I'm looking through that source code to see how they are implementing their policies and their controls. Secondly, there are a lot of APIs that are immutable in AWS. They start with like describe or get or list. Like I can say list buckets or list policies or list users, and that can give me an idea of what is in the environment, what is going to constrain me. So there's a couple different ways to identify preventive controls. Then I want to understand the AWS service that I'm attacking. So in the event that that my target is using a service I've never used before, I need to understand that service to understand how I can get access or complete my objectives. So I love to just search on my favorite search engine, Start Page, or GPT, and see what are the actions, resources, and conditions for the service. So this is my search query string, right? Like S3 actions, resources, conditions, or IAM actions, resources, conditions. And that will give me a listing of all the things that service can do. And then the next one is just reading, AWS calls it the user guide, but it's RTFM. So just reading the manual or reading the user guide or the developer's guide to understand that service. But in understanding the service, then I have a good idea of how to potentially find vectors. So now I've got a good lay of the land, and I want to try to advance, right? Like in traditional hacking, this is like your exploit, right? This is when you've run your Nmap scan, you've identified there's a Windows server that is vulnerable to MS17010, and you run the exploit. So here's where we advance. So we found a gap in our preventive controls. We're able to add ourselves to an administrative group. We're able to create new access keys for a particular administrative user. So we find that gap and we take advantage of it to get new access. Excuse me. And in doing that, that expands our sphere of presence, right? We can now see new things. We have different access that we didn't have before. And so with that access, what can we get? So I'm looking for things like, secrets, credentials, API tokens, more access to more resources to better understand the environment. So it ends up kind of being this cycle, right? You don't really stop until your objectives are completed. And it's kind of weird when I diagrammed it out like this. I was like, it looks familiar. It looks kind of like what I'm thinking about. Looks like a cloud. Strange. Sorry, let me just grab some water. One moment. We'll go back to the cloud. This is cool. All right. Okay, so other ideas to consider as you're thinking about how to do well at hacking. And one of the things I love CTFs. I love CTFs because they're test environments, right? Like you crash something in a CTF, no big deal. But if you crash something on someone's production server, it might be a big deal. Same thing with AWS accounts. You can make your own AWS account so that you're ready to compromise and do whatever actions inside of your target's production account or wherever you're actually testing. One of the nice things also with the separate AWS accounts is that there's a free tier, so you can potentially have like no cost for learning how to better hack your targets. Second part, infrastructure as code, right? I love writing things in Terraform or CloudFormation so that it's very easy to track and manage versions. And, then I have access for things like searching for how did I do this previously and how do I build something new off of what I've previously built. And then keeping notes on everything. So pick what works for you. Everybody takes notes differently. Pen and paper, I like Obsidian, OneNote, like whatever you like, right? Just find something that works for you, but make it searchable so that you can go back, reference things easily, synthesize new information easily. Okay, so I think this is our last section. I think policies. So again, does our AWS environment prevent, detect, and alert the things that we're talking about here, these situations? All right. Oh, wait, I'm in roles. Oh, we got two sections, roles and policies. Okay, so this is cool. Add role to instance profile. You're spinning up an EC2 instance, and that EC2 instance needs to talk to some other AWS service. So you can do that by passing roles into these instance profiles. So you can say, this EC2 instance needs to talk to this S3 bucket to get files to then perform some kind of processing as an example. So let's take a look at that in action. So I was in this environment, I could do things in EC2, like spin up VMs, but I couldn't do anything with S3. So here is my current low privilege access. I have this compute role. And I want to get into this S3 administrative role. And again, we access a role by assuming it. So we're trying to assume into this role, but it says, nope, you can't do it. Access denied. So I'm like, can I just list buckets? Can I do things in S3 right now? Nope, still denied. So I have no S3 options. So what I did is I had an instance profile that I was able to create called compute profile. And then I told it, hey, when the compute profile is used, have it use this S3 admin role. So even though I can't directly use the S3 admin role right now, I might be able to spin up a VM, an EC2 instance, and have the EC2 instance use this instance profile, which then can access the S3 admin role. This is kind of like a sneaky hop. So here we're creating a new EC2 instance. I think this is just like a Amazon Linux image, but we told it, use this compute profile to which I had added the S3 admin role. So now we have a new EC2 instance that's running on the internet, and we're going to get a shell into that instance. It's ours, so there's no exploit here. This is just accessing, the new VM that you created. And so here we are inside the EC2 instance. Again, we're trying to get access to this S3 admin role. So now we have the S3 admin role access because of the instance profile. And so now we should be able to do S3 actions like list buckets. And in this one, I wanted to get into the assets bucket. So that's how I was able to bypass the controls from where I was with my original just compute role. So with adding a role to the instance profile, you do need this permission of IAM pass role, which is great if you ever have this permission. It's very useful for other privilege escalation paths. And there is a limit, one role per instance profile. So if you try to add a second role onto an instance profile, you'll get an error that occurs. But you can create a new instance profile and then add a role onto that potentially. So you're always trying to find a new way to get roles added to these instance profiles that you can use. All right, creating roles. So in this case, I was in an environment where they had paths that they considered to be privileged. So if you notice down here in the bottom right, hopefully folks can see, there's this /admin path. So if you are in a role that's in that /admin path, you have like additional privileges. The policies like would deny certain actions for anything outside of this admin path. So I want to get into this IAM admin role, but I can't. But I can create a new role and get into that, allowed me to get into that admin path. So the compute role is where we start again. We just have some EC2 privileges. I wanted to create a new access key for API admin, but turns out I can't. Access denied. So I'm thinking like, how can I get access to this API admin? So I was going to create a new role. And roles have what's called an assume role policy or a trust policy that says who is allowed to access that role. So I just have a file that says the compute role, my current access, is allowed to access this new role that I'm going to create. And I'm creating it in the admin path, which is privileged. So in this case, the gap was that they allowed this compute role to create a role in the admin path. That there was a gap in the the authorization controls. So here we go. We've created a new role. We've added my policy to it that allows the compute role to assume into this int80 role that's in the admin path. And so now, when we attach the role policy, we'll give ourselves administrative access, which allows all actions on all resources. So basically like having root almost. And I'm going to take a drink of water while I type on screen. So now I've got admin access to my int80 role. And we're going to assume, remember I'm still in my compute role at this point, but we've created the administrative role. So now I'm going to assume into the administrative role. And so that's done with that STS assume role call. So now we can see, cool, I'm in my int80 role, which does have administrative privileges because of its admin path. And now I was able to create new access keys for the API admin. So that was how I was able to priv in that particular case. So my philosophy around AWS environments is that I think they should be self-service, where people can create their own roles, but you should make it so that something like attaching an administrative access, an admin access policy still is constrained. The role is still constrained. It can't do things outside of what you originally intended for it. And we'll talk a little bit more about that at the end. So again, does our AWS environment prevent that? Does it detect or alert on it? Last sections, IAM policies. So IAM policies have versions to them. So you can create an IAM policy, you can make a modification to it, it creates a new version of that same policy. And so in this situation, I couldn't attach a policy and I couldn't put an inline policy on the target principal that I wanted to compromise. But what I was able to do is look at the version of the policy that was already attached to that principal and then just go in and update it, make a new version of it that gave me access. So let's see. All right, so this is my starting access. I'm in my compute role again, low privilege, and I expect I'm probably trying to get to the API admin user. Okay, yeah, so I'm trying to create access keys for this target API admin, denied, but there's no policy that allows this action. So this is a little bit different because now I'm thinking like, okay, can I modify the policy somehow or create a new policy that does allow that action? So I wanted to see what policies are attached to my current role. This is our recon part, right? Like where are we? Let's get the lay of the land. So first I have to find out what policies are attached. And so we can do this through the list attached role policies API, and it tells us you have a compute policy, you're allowed S3 buckets, S3 list buckets, and EC2 full access. So I'm like, well, this one looks custom. Allow S3 list buckets. So let's take a look at that one. Because the Amazon EC2 full access, that's like one that's created by Amazon, so I don't doesn't seem like a good target to modify. But perhaps this like allow list buckets will be good. So they're telling me it's on version 1. That's the V1 there. So I'm like, cool. Show me what version 1 has. What's in the policy? And we're going to query this a specific way so that it's cleaned up and we get a clean look at the document. So we can list objects, which are files, and we can list buckets, which are the containers for the files. We can do that on any bucket or any object that's in our account effectively. So now I'm going to make my own policy. This is the same AWS administrator access policy, just copied to a local file. And I'm going to create a new version of the policy that's attached to the API admin. So now I'm going to say, hey, that allow S3, or I'm sorry, the policy that's attached to my current role. The allow S3 list buckets, it's actually not an S3 policy anymore, it's an admin access policy. So now I've got version 2, but that version is not default, right? So version 1 is still in effect. So I need to go in and say, hey, the version that should be in effect is actually version 2. So we do that through the set default policy API, and we just say, yep, version 2 is what's up. Use that one. Use the admin access. So now I've got version 2, which is full admin access applied to my current role, and I can go in and create an access key to give myself access to that API admin user. So that was fun, priv-esque. Cool. So a couple different ways that you can go about this. So say that you don't have create policy version, right? You want to try something different. Anybody here ever looked at GitHub repos and gone back and found previous commits that had secrets or passwords in them? Yeah, awesome, me too. So you can do the same thing here, right? You can use get policy version to go back and look at previous versions of the IAM policy that you're targeting. Find one that's possibly more over-permissioned, and then you can say, use that more over-permissioned previous version. It works, it's easy, it's great. This one's kind of weird. This was very specific. I was in an environment that had this like governance mechanism, and it would basically try to maintain state for the environment. So if it saw like this IAM role is missing an IAM policy, it would like try to put the IAM policy back. So what I was able to do was detach the policy, delete the policy version, delete the policy itself, and then create a new policy with the same name. And so what happened is the governance mechanism, like when it came back around, it was like, oh, the allow S3 list buckets isn't attached to the compute role. Here, I better attach that. And that new policy that I had created was like an admin access policy. So it was like a very specific like thing for that situation, but it worked. So super fun. Ways to think about this, right? Deny anything, to unprivileged users or access around policy versions. Just don't let low privilege things tamper with administrative policies. Or use something different. I like SCPs a lot. These are service control policies. They apply at the organization level. So you can say like, I have to manage 4,000 AWS accounts. How do I do that? Well, you use this AWS organization, and then you use these service control policies that cascade those controls across your organization. And the point of that is that like they're out of band from the individual IAM entities. Detaching a policy. So in this case, kind of like the group thing where I was in the group that was restrictive and just removing myself from the restrictive group got me more access. Same thing here. Like I've been in situations where there's a restrictive policy that's attached to my current IAM principal, and by detaching that restrictive policy, I just got more access. So it's another gap in controls, but again, it shouldn't work, but it's worth trying. Sometimes it works. 1% of the time it works 95% of the time. So in this case, I have this S3 role. I can do S3 things like list buckets and print them in a nice format, apparently. So there's analytics data, there's assets, and then CloudTrail logs, which have a lot of fun CloudTrail hacks if you're interested and ever want to talk about trying to not get caught in AWS. AWS has 3 API list objects, so I'm trying to then see what is in this analytics data bucket. Like I want to get those files. And it's like, oh, the company financials. Like, okay, yeah, I'd like to get the company financials. So if we try to download that, we say, please give me the company financials, it would say, you're not allowed to do that. Spoiler alert, access denied. So there was a restricted policy that was limiting what I could access. Even though I had S3 access, this restricted policy was preventing me from getting the assets that I truly wanted. So again, we're in this S3 role. We want to see what policies are attached to our role. And it says you have this S3 view only, IAM policy, and then Amazon S3 read-only access. So I said, let's take a look at the S3 view only policy, which sounds like what's probably limiting me, right? I can see things, but I can't get them. I can't get the content. I can view it. So if we take a look at the policy, I think we probably have to get the policy version first before we can see the contents. Yep, so it's v1. Now let's get the actual contents. So we're getting the version of the policy that's the default v1. And putting it in a nice format. And so we can see, okay, you can get some objects, but actually you can't get any objects, you're denied, right? So the effect when I try to do a get object API is that it's denied. So this policy is the one that's restricting me, it's what's limiting me. So I was like, can I just not comply with that policy? Can I just detach it and like not use it? And it turned out that I could. So in detaching it, it said, sure, no problem. There was a gap in the authorization mechanism there that allowed me to detach the restricted policy, which then allowed me to download the company financial data from the bucket. Go, take faster. And I saved it in temp, like all good hackers do. Cool, and so there I was able to download the stuff. Yep, cool, company financials. So again, this is like the inverse, right? Instead of giving myself more permissions through adding something, I took away the restriction, which then gave me more permissions. So yeah, your mitigation there is to prevent unauthorized modifications, right? You want to make sure that people can't go in and tamper with the authorization mechanism. So yeah, the content of the policy itself, right? We've shown changing the policy. We've shown messing with the attachment. So yeah, that's pretty much it. That was just kind of like a whirlwind tour of like random pen test stories and strange privilege escalations, most of which I didn't think would work, but they did. So yeah, I love AWS. I didn't start using AWS until, I don't know, a couple of years ago. When I started in that role, my manager said, go make an IAM user. And at the time I had no idea what that was. And I was like, okay, I'll try. The environment that I was in was set up in a way that you couldn't make IAM users. They had all these controls in place that did federated authentication. You couldn't create IAM users. The next day, I was like, hey, I created an IAM user. And he's like, what? How? and I was like, I showed him, and he was like, wow, that's really cool. And being a hacker, as soon as I get access to something, I'm like, how am I going to get caught? Right? You go and look at like erasing your shell history and look at log files to tamper with. So I'd like tried all this stuff with like, how do I mess with CloudTrail? The CloudTrail was like really protected. I couldn't do anything, but I did turn off guard duty. So I told my manager like, oh yeah, also I turned off guard duty. which is like the intrusion detection in AWS. And he's like, what? He's like, that's really bad. He's like, that's awesome, but it's bad, so I have to turn it back on. But that was like my first like AWS pen test. Basically, on the second day, I like bypassed all the controls of this organization, and it was like at a big tech company where I ended up leading public cloud security, and we had like thousands of AWS accounts to manage. A lot of stuff that I learned gave me ideas about looking for these kinds of things in other environments as I moved forward. So again, your key is, like, as we've shown, you have to tightly control any mechanisms that are used for authorization. This is me on the internet at int80. In America, there's like this data that shows if you really liked something, you'll tell 2 people about it. Whereas if you didn't like something, you'll tell 11 people about it. So if you liked this talk, please follow me at int80 and tell 2 friends about it. And if you did not like this talk, please follow me at int80 with 11 different accounts and tell me why you did not like this talk. Please go hack all the AWS environments, and I will see you tonight at the party where we will hack all the things together. Yeah. Thanks. ¿Tiene preguntas en inglés? ¿O alguien puede traducir?
You talk about abuse. You talk about how to abuse from the IAM credentials, but what is the most commonly way, or how could I solve it from an AWS manager, man? You know.
From an external perspective, or?
I don't know. Maybe it's all companies gonna be have a administrator of AWS. How could I get those credentials from him? Which is the mostly common way for getting it?
Yeah, so excellent question, which I think if I'm understanding kind of what you're asking is like, how do I get the initial access to begin? Yeah.
You were talking about the abuse about it.
Right.
How could I get it?
Yeah, so I already have some access, right? I have low privilege access in these demos, but how did I get that low privilege access? And there are a number of different ways, right? Like a favorite is like looking through GitHub, source control, GitLab, and finding credentials that were committed into source control. You can do that internally, right? Like companies have their own internal GitHub. If you get access to that GitHub, you can look through their internal source code, find it. Application vulnerabilities, right? If you find like an SSRF, a server-side request forgery, running on an EC2 instance, EC2 has a mechanism called instance metadata service. You can use the SSRF to query the instance metadata service and return credentials back out to you. AWS tries to mitigate that through version 2 of IMDS, instance metadata service. But if you have something like an RCE, remote code execution on that EC2 instance, you can have a shell and bypass those protections for SSRF to still get credentials out. Other places, you'll find credentials in environment variables. So if you get a shell on somebody's laptop, for example, or like on a server where like in a container and the credentials are passed in the environment variable, look at like the environment and you can pull the credentials out sometimes. Sometimes you'll also find them if you have like a local file read. You'll find apps that are structured where there's like a .env for like environment, and then you can use the local file read on that .env to pull environment variables out. Same access into those credentials. You compromise someone's laptop, the AWS CLI is configured with files by default under this like .aws subdirectory in the home directory. So if you go like looting through there, you can pull the access keys and credentials out of there as well. So there's like a number of ways you can get your initial foothold.
This credential is stored in the administrator laptop in clear text.
Oh. Yeah, in some cases, yeah.
Huh?
Yeah.
By default?
So it depends on the setup, but sometimes, yeah. I know, right?
Hey David, how are you?
Hey, I'm doing well. How are you?
I'm fine. Well, first, thank you for the presentation and for score for your music. It's so inspirational.
Thank you.
Yeah, I have only one question, and it is: if you have any plans about the implementation of this same methodology, but now in a multi-cloud environment, or if you have seen something about it?
Yeah, great question. So I don't think about this in a way that, like, you know, if I understand your question correctly, you're probably thinking about it in a scalable way where you have like some kind of framework that you could say, like, I have GCP credentials or I have Azure credentials. Now, like, go look through like all the Azure stuff. But just like how like Metasploit would have like priv modules, right? And so I don't have any considerations for that because I tend to be very hands-on keyboard and like manual when I'm cruising around a target environment. But I like your idea, I like where you're thinking, and I think you should build it. And then let me know, and I'll be happy to submit pull requests. I will mention there is like Paku is like an existing AWS framework that's like Metasploit, and there's no reason that you couldn't extend that to like other cloud platforms, for example.
Hey, do you think any of this is possible if you're only giving like a viewer account or like very restricted account with only security reviewer or something like that?
Yeah, it depends on your current access, right? A lot of this is like I start with a low privilege access. But there's some gap in the authorization mechanism, right? Just like my first story with like being able to create an IAM user, this entire environment that I worked in was like for my first cloud job was like orchestrated in a way that prevented static credentials. So like you weren't able to get IAM users. And the way that I did that was I found a gap where there was an administrative role that was allowed to call the create user API. And I couldn't assume that administrative role directly, but I showed like the trust policy, right, the assume role policy. I was able to update the assume role policy that was attached to that administrative role to then say, I'm allowed to assume into that administrative role now. And so that got me the administrative role access, which allowed me to create the IAM user. So in some cases, like I'm sure there are AWS environments out there that they have very tight, controls. In this case, in all of these cases, I was able to find some gap. There's always something somewhere, I feel like. I don't think I've met an environment that I couldn't hack. Not that that's a challenge, but given enough time, like we can always get into everything.
Just for better understanding of the technique of the detached policy, and that technique could be effective because the default policies are allowing, or is because the policy you detached is overlapped another that have allowing rules?
Great question. Yes, that one worked because the default was set to allow, right? So in an AWS organization, what you'll see like at the root is a policy that's called, I think, full AWS access, which grants allow onto like everything, and then you constrain the access by attaching like deny service control policies. AWS by itself in a single account is a default by deny. It's an implicit deny. So if you create a new role and you assume that role, but you haven't given it any permissions, you won't be able to do anything in that role other than get caller identity maybe. But like if I created a new role, assumed that role and said like list buckets in an individual AWS account, it wouldn't work because of AWS IAM's approach to permissions, which starts with an implicit deny, then it looks for an explicit deny, then it looks for an explicit allow, and then eventually returns to implicit deny. And whatever it finds first, that's where it stops.
Okay, no.
Oh, that's it?
Yeah, I think so. Okay. Thank you so much.
We'll hack all the things tonight together.